Hello students, welcome to the course Object-Oriented Programming. In this course, we will dive into the concepts of object-oriented programming with the help of C++ language. Okay. So, the first question is, what is object-oriented programming? Object-oriented programming is an approach which revolves around the concept of an object. Now, what is an object? Object is an entity which combines into a single unit both the data and the functions which operate on that data. In a program, we have some data and we have some functions which operate on that data. For example, you write a program to calculate the square of a number. Okay, so in this program, the data is the number whose square you have to calculate, and the function is responsible for calculating the square of the number. Okay, so the function is operating on this data. Okay, so there is a data and there is a function which is operating on this data. So the object is an entity which binds together these two things, the data and the functions which operate on the data. Such a unit is called an object. Okay. So the next question is, why do we need object-oriented programming? Object-oriented programming was developed because there were limitations in the earlier approaches to programming. So what were the earlier approaches to programming? There were basically two main approaches, the procedural approach and the structural approach. So the earlier languages followed the procedural approach. Later the structural approach was adopted. Okay. So first we will understand what are the procedural languages. C, Pascal, Fortran and similar languages, the languages used at the very beginning were the procedural languages. Okay. In the procedural languages, each statement tells the computer to do something. Okay. Each statement is an instruction to the computer to do something. For example, get some input, add these numbers, divide by 6, display that output, like this. Okay, so here these can be viewed as statements. Okay, and each statement is telling the computer to do something. Okay, so such type of programming approach is called the procedural programming approach. Okay, so program in a procedural language is simply the list of instructions. Okay, so one thing was division into functions and the second thing is division into modules. The idea of breaking a program into functions can be further extended by grouping a number of functions together into a large entity called a module. Okay, a module is nothing special. This is just a collection of functions. We can put a related set of functions together inside a module. Okay. So this is the structured programming. Okay. Now, what were the problems with structured programming? As programs grew even larger and more complex, even the structured programming approach showed signs of strain. How? It has two reasons. The first is functions have unrestricted access to global data, and the second is unrelated functions and data, which is the basis of procedural programming. They provide a poor model of real world. So we will understand these two things in detail in the next slides. So the first problem is unrestricted access to global data. So for example, take an inventory program. Inventory program means the program which is written to manage the items in an inventory. And inventory can contain any type of items. For example, the inventory contains furniture items, tables, chairs, etc. Okay, so here we have some global data items and some local data items. So first of all, let us be clear about what are the local data items and what are the global data items. Global data items are accessible to every statement in the program. They are accessible to every statement in the program. So every statement can access this global data and modify it. Okay. And the local data, they are accessible only inside the block in which they are defined. They are accessible only inside the block in which they are defined. Okay, so they can be accessed only by the block. So for example, this is a block. In this block we have created a data item X. So inside this block we can access X. We can modify it, we can display it, we can play around with X inside this block. But outside this block we cannot access X. This is not allowed. But the global data items, on the other hand, they are accessible to every statement. Okay. So here in the inventory program, the global data items are the collections of items in the inventory. Okay, what are the items? For example, tables, chairs, the number of tables, the number of chairs, etc. so on. Okay, so the various functions can access this data because they are global. So functions can access this data to input a new item, display an item, modify an item, and so on. So this is the inventory program. Now this is the scenario. Okay, so we have the global data items, and these are the all the global data items here, and these are the functions. This is a function A, this is a function B. So function A has its own variables which are defined inside this block. Function is also a block. Okay, so the function A has its own local variables, function B has its own local variables. So function A can access these local variables and it can also access the global variables. Similarly, function B can access its own local variables because they are inside this block, and it can also access the global data items because the global data items are available to every statement. But the function A cannot access the local variables of function B. Similarly, function B cannot access the local variables of function A. Okay, so what happens with global data in procedural paradigm or the structural paradigm? The global data item is unrestricted because it can be accessed everywhere. Function A, B, C, D, all these functions can access this global data item. There is no restriction and all these functions can modify this data item. So any function can modify any data item accidentally, which might result in the program behaving wrongly. Okay, so this is the problem with the unrestricted access. In a large program, we have many functions and many global data items. So the problem in this scenario is even larger number of potential connections between functions and data. So we have global data items, a large number of global data items, and we have a large number of functions. So what is the possible number of connections between this data and these functions? Multiple. Okay, very large number of connections. Connections here mean which function is accessing which global data item. Okay, so this will make the program structure difficult to conceptualize. This is our second problem. Conceptualize means we cannot understand the flow of the working of the program. Okay, so it is unable to model the real world. Okay, so it also makes the program difficult to modify. Why? Because a change made in a global data item may necessitate rewriting all the functions that access that data item. For example, if we change the data type of a global data item from short to int, okay, and a large number of functions are accessing it, okay, and we have to then modify all these functions so that they can handle this change from short to int. Okay, so it will become very difficult to manage. In our inventory program, changing the product codes for the inventory from 5 digits to 12 digits, this is the same scenario. Another example, we are changing the code of the item from 5 to 12 and a number of functions are accessing. So we have to modify all of these functions in order to handle this change in this global data item. Okay, so this same example from 5 to 12 might necessitate a change from short to long data item. All the functions that operate on data must be modified with in order to deal with a long data type instead of a short. Okay, in a large program it may not be easy to tell which functions are accessing which data. Okay, because there are a large number of potential connections between the data and the functions. Even if you figure this out, even if you figure that which functions are accessing which data, modifications to the functions may cause them to work incorrectly with other global data items. We are changing a function because there is a change in a global data item, but as a result of this change, this function might work incorrectly with respect to another global data item. This might happen because everything is related to everything else. So modification anywhere has a far-reaching and often unintended consequences. So this is the second problem. So now we say that we are able to handle these two problems, the problem of unrestricted access and the problem of poor modeling of real world data in object oriented programming. How? We will see this with the help of an example. Here in the object oriented programming we use the concept of objects. So what is an object? As I already told you, object is a collection of data and the functions which operate on that data. Okay, so the real world also has entities, for example car, which has some attributes and which have a behavior. Okay, so attributes are the properties of the real world entity. Here the car has attributes like horsepower, number of doors. It can also have many other attributes, and car also has a behavior. Behavior means how it is behaving, how it is operating. So behavior can include apply brakes, it can also include change gear, press accelerator. Okay, these are the behaviors. Okay, so we are able to model this car as it appears in the real world using the object-oriented programming. In the physical world, we deal with objects such as people and cars. Such objects are not like data and they are not like functions. Complex real-world objects have both attributes and the behavior. Okay, and when we model this, the attributes become data and the behavior become function. Okay, so in this way we are able to model the real world data. The fundamental idea behind object-oriented languages is to combine into a single unit both the data and the functions which operate on that data. Such a unit is called an object. Object, as I told you, has data and functions which operate on that data. Okay, so the functions inside an object are called member functions. The object's functions typically provide the only way to access this data. This data cannot be accessed by any other means. This data can be accessed only by these functions. So the data is hidden, it is safe from accidental alteration. This solves our second problem of unrestricted access. The data is not unrestricted anymore. Okay, and the data inside an object is called data members. Okay, so the data items in an object are referred to as data items, also known as attributes or instance variables. Okay. So this object-oriented programming also provides us the message passing. A C++ program typically consists of a number of objects which communicate with each other by calling each other's member functions. Okay, so here in this example we have 3 objects. Each object has its data, each object has its member functions. So as I told you that only the object's member functions are able to access the object's data. Okay, similarly this data can be accessed by this object's member functions. This data can be accessed by this object's member functions. So what if this object wants to access this object's data? It has to call its member functions. Okay, and this thing is called message passing in object-oriented programming. When the member function of this object is calling the member function of this object, so this object is passing a message to this object. This is called message passing. Okay, calling an object's member function is referred to as sending a message to the object. Okay, so we can understand it in more depth using an analogy of a company. For example, a company has 3 departments: sales department, HR department and accounting department. Okay, sales department has sales data which is handled by sales manager and secretary. Similarly, HR department has employee data which is handled by HR manager and HR staff. Accounting department has financial data handled by chief financial officer and financial assistant. Okay, so now what will happen if the HR department wants to know about the sales data of a particular employee? Okay, sorry. So what will happen if HR department wants the sales data, the number of sales done by a particular employee? It cannot access this data directly. It has to ask the sales manager or sales secretary. So the HR manager will send a message to the sales manager that kindly provide me the sales data of Mr. XYZ. Then the sales manager will retrieve the required data and send it back to the HR manager. Okay. Similarly, if the accounting department has a financial data, the sales department wants to access this financial data, its sales manager will send a message to the chief financial officer. The chief financial officer will retrieve the required data and then it will send it back to the sales manager. Okay, this is how the message passing is working in the C++ language or object oriented programming languages in general.